we reached one of the most fun part of the whole video, I think. We reached the gameplay. Let's open the notes and let's just write here gameplay. Okay, and I copy paste a long description I prepared before. So let's quickly walk through it. I'm not sure how familiar you are with this game, but I briefly introduced it. It is pretty simple. We have these kinds of game elements like the player character, the wall, gems or gold, the rock represented by a big O. That's not a 0, but it could be a 0 as well. The earth is represented at the moment with a dot, and the space with a literal space character, and E as an exit. Okay, and here is a couple of rules. These are not all the rules, but the most important ones. So the player can dig a tunnel through earth. So basically you can eat these, and after you leave that place, there will be empty space. That's how we can dig a tunnel. Rocks and gems, basically they are behaving mostly the same in many rules, except the player can pick up gems, but not rocks. Rocks, gems, they fall down when there is a space below them. So there is gravity. Rocks, gems falling on the player's head ends the game. Player entering exit ends the game. That's the win scenario. Player can't go through the wall, which is represented by an X, and they can go through the rocks. Player can collect gems, but not falling gems. So here are some composite rules. So here is a small snippet of the board. So 2 rocks are on top of each other, and both left and right side there is earth. So this is stable, nothing happens. Well, assuming that below that there is something that supports those rocks. Now this is unstable. There are 2 spaces behind them and 2 rocks on top of each other. So the top will roll to the left. First here and then here. And this is symmetric. Then the top rock will first move here, like this, and then we'll move here, like this. Okay, now this is stable. The rock don't fall off the walls. Well, this is just a decision. Of course, we could implement it in a way that in this way the rock will also fall down, but we decide to not do that. Rocks and gems behave very similarly most of the time. Yes, I already mentioned this. The gem can kill a player character if it falls on their head. Now this is an interesting one. You can create interesting levels with this extra rule that the player can push a rock horizontally if there is an empty space behind it. So the player character is here, and if we try to move to the left, there is a rock there, so we can go through that. But in this case, the rock will move there, and the player will move with it. This is possible, and the same for the right. If you move right, then this will be the next stage, in the next screen. Okay. Now this is not an exhaustive list of all the rules that there could be, but just implementing these, I think it already provides a fun game. You can create fun levels for it. Okay, so this will be only about stage 5 is only about the gameplay. I hope it's one word and not like this. Let's save this and let's move to the code now. So first of all, we don't need these, I think, for a long time. Less lines are good. And this is the best place to add some new stuff to our game state. We can add, for example, the gems collected so far. I think that's a good step. And we can also add some flags for the end scenarios. We'll just use some integers. So gems collected, are we dead, did we win? Yeah, that should be enough for now. So the gameplay code will take place mostly in the update function. The render, we want to keep the renderer dumb. Later it will deal with the colors, and so it will deal only with the display of the game state. The update deals with the game state itself. By the way, maybe it's a good place to mention that of course we are using these characters also as display elements, but they don't have to act like that. So for example, for the Earth, I'm using a dot at the moment, but in the very end, I will just use a background color and no dot. So there is most of the display elements and the game state are the same, but they don't have to be. These are two different things, and that's where the update function, the render function, will get some smarts. Okay, where is our update function? Okay. Now this is again a decision that we want to keep the handle player as the first thing to do. For example, if you move to the exit in the handle player's state, then you immediately win. Nevertheless, if the rock falls in the next moment on your head, that's okay. You still won. What else? Yeah, for example, if you start, there is an avalanche. You dig up a tunnel to the top, and there is a rock above you, and then you start running downwards. I think that's one of the funniest part of these kind of games. And there is an avalanche falling on your head. Then the handle player must be above everything else. Let's call this update all events. So the handle player, if it's above it, then you can run ahead of this avalanche. Otherwise, in the update all elements, the rock will fall on your head, and then in the handle player you will try to run away from it, but that's too late. So this is an important decision we make here. And of course we will change the handle player state, handle player function. Okay, what is this update elements about? This is where we will do everything else, where we will implement all the game rules we talked about. But first, let's start with the handle player state. This is exactly here. So currently, the handle player state works only with the knowledge of the board, and that's not good. We don't need this knowledge anymore. In fact, that's a wrong thing. The handle player should only make local decisions, and this is, I think, important. That we will look only around a very, very tiny radius of elements, and that makes this is an important decision, because currently we have a global knowledge here, and it enables us to make funnier game elements later. For example, like you can create a teleport. And you just make if you make only local decisions, then it's easier to argue about such changes. So let's remove this type of thing. So this is a knowledge about the board, that the smallest y coordinate is 1. Instead of that, we will make a local decision against is there a wall element above us, because this is the up state. So if there is a wall element above us, then we made a local decision that we can go above it, and we can remove this global one. Okay, let's start doing this. This will be a bunch of if switch cases, which might be a bit intimidating, but it's very simple to write them. So you just have to get used to it, I think. We are not done with this part, but let's take a look at it now. So the question is, we are in the up state, so we take a look at the what's in above us, position y minus 1. That's exactly above us. And if it's a gem, then we just collect it. And if it's an empty space or an earth, then we do the previous thing, that now our current position is empty space, and the new position we move there the character. And these three share this part. There is a fall through here, except we collected the gems. Now, what else can be above us? There could be a wall, which is handled here. There could be a rock. At the moment, this is handled here. And yeah, we did not handle the exit. If there is an exit above us, then we won the game. So let's add those as well. And then after that, we will still be not done. Okay, let's think about now falling rocks. Now we will make a decision here. I don't know where to take a record of this. So when a rock starts to fall, for example, there is an empty space below it. How to represent this? So in this case, what I want is that on the first part, I want to signal that this rock is falling. And I will represent this with a small o. And this will be the first update. After the second update, the rock will fall down. And then if there is earth or wall below it, then in the next round, it will turn back to a normal rock. So I will make I will differentiate between rocks and falling rocks. And same for gems. Why is that? Just think about that the player can move below a rock. This is perfectly okay. I want this to be perfectly okay. But moving below a falling rock is not okay. Then the player dies, because then this rock came from above somewhere. And this is the reason why I want to represent these states differently. This is a choice I make now. And yes, we have to deal with these cases differently. In the representation, we actually should represent the small o and big O states in both with like this, because the rocks don't compress. But if you maybe catched it in the first video, in the beginning of the video, that I did not do that. I actually bring out the small o. The reason is that because I just liked it. It looks like a small animation, and I liked how it looked like. That's so. But basically, that's a bug, because we should differentiate. These are both representing rocks. Okay, let's add the remaining cases. So this is the small o. And as I said, the gems and rocks are behaving the same. So there will be a state for falling gems as well, because we can move below a normal gem, but we can't move below a falling gem because we will be dead. And the letter S looks very similar to the $ to me. So that's why I chose this character to represent the falling gem state. So these two states we handle exactly the same at the moment. And that's basically mean that we are dead. So we moved up, tried to move up from a falling state. And these two, the S and the $ are exactly the same. But here we just collected the gem and eat it, or put it into our bag. In this case, we are dead. I will not break down all the decisions like this. I will, but I wanted to go through my thinking for one of the switch cases. And I think this is pretty simple. All of these are very, very obvious local decisions we are making here. Except the code is a lot, because there are so many rules. You can't implement this in a short code. So let's do the rest now. So here is the case 2, which means that we try to move down. We can see this by checking the position +1, so that's below us. Same, if there is a gem there, then fall through. If it's earth or space, then we just move there. If it's the exit, we win. If we go to a falling rock or gem, then we are dead. This is actually, maybe let's remove this. Yeah, I don't think we should be dead here. We just don't do anything. Okay, if we move to the right, we can see this from position X +1. Then very similar decisions. Now, this is the interesting part. If there is a rock there, then we check whether the position +2 there is a space. That means we can push the rock. Then we update all three things to its correct value. So the rock will move to the +2, the player move to the +1, and we leave an empty space. This is pushing the rock rule. And same for the left. Okay, that looks okay. Now we have to implement this update all elements function. What does it get? Again, we make a decision here. So we iterate over all the pieces of the board from the bottom and from the right, like this. And this is a decision. I came up with this because of gravity. I thought that I will move the rock below. I will move the bottom rocks first down before I move to the rocks to the above them. That was the only idea. I'm pretty sure that this doesn't really matter. You can iterate from the top to the bottom as well. Maybe some things would look a bit differently during gameplay, but I think it should mostly work the same. But this is the fun part. You can play with it. You can change these things. So here is it that I am moving from the bottom to the top and from the right to the left. And based on the screen, on the element of that screen, for walls we don't do anything. The only interesting parts at the moment, because we don't have any enemies, is the rocks and gems. And we have two kinds of rocks and gems. We have the big O and $sign and the small o and the S, which these two represent the falling rocks and gems. And we will put them into different functions. We don't have to deal with the exit or the player because we already did the player differently. We already implemented that. What else? Yeah, the earth doesn't do anything, and then the space doesn't do anything. Okay, let's implement, for example, the handle, rocks, and gems. So we record, these can be gems or rocks as well, just based on the name. So we keep a record of what we have. And these are not falling gems or rocks. That's important. So this is one of the moment. Then if there is a space below us, then we switch their state to falling ones and return. Nothing else happens with them. It's like in the cartoons that they run off the cliff, but at that moment they just panic. They are not falling down. Okay, what is this next one? Yes, and this is about the rule about the composite rule of rolling to the left or rolling to the right. If below me there is a rock or a gem, then I check whether there are two empty spaces to the left side to me and the left and below that. If that's the case, then I mark myself as a falling entity. So first I check the left and then I check the right. Now this means this is a hidden decision here as well. Things like to move to the left. Although, okay, we are just marking them as falling. But if we keep this in the other function about where we will handle the falling rocks and gems, that we first check the left and then the right, this means that if they have a decision, they move to the left. Again, this is fine. We could randomize it, or I was playing with the idea to every other iteration, every other update, then we will flip where we go. First to the left and then to the right. You can play with this. I leave it like this because even like this, it's fine. It looks okay. You know, these are just happy accidents, not bugs. Okay, the last function is sadly doesn't really fit on one screen. It's about handle falling rocks and gems. So in this case, we check whether there is an empty space below us, and in this case, we start falling down. That's handled here. And then this is about the rolling. If there is those two empty spaces to the left, this is what I was talking about, then the gem or the rock will move. Yeah, this is a too good code. We will move this back later. I will tell you later what those two were. So if we roll to the left, then and we are a gem, then we move this. We start rolling, so we move it to the left, both the gems and the rocks, and to the right, this is the same. What else we have here? Yes, if below us there is a falling rock or a falling gem, we just return. We don't fall with them together. Again, this is just a decision. Oh, yeah. And if there is a player below us, then the player is dead. That's also important. Yes, and if none of these happens, this means that there is either a wall or a rock or No. Yeah, a rock, not falling rock, or earth below us, and then we will just stop being a falling rock or a falling gem. That's this last part. Okay, this was a big one. I think we have enough to test it, but we need a better level. So let's create a better level now. Just very quickly. How quickly can we do this? So maybe let's create a room with lots of rocks and gems, because that is always fun. And of course, we should test whether we can, these internal walls, we can move through them. Let's put tiny earths there to plug them in, and just a few earths here. Maybe I put an exit there, although I don't think we handled the exit. Yeah, we did not implement that. Anyway, I just put it there. Okay, this looks enough. Let's now compile. Oh, it compiled. We already saw some avalanche happening, because there were room to the left and the right, and they created a pyramid. We can walk around, and I can't move through this wall anymore. Amazing. I can eat the earth. I probably now flipped the state of winning over, but nothing happens because we don't handle it. And now I will move this this plug in, and I will try to run away. So we are not dead, because the gem above us is not in a falling state, but soon they will be. So two things we should check: whether the rocks and the gems will switch to these big S and small O state, and just how they behave as a collective. Yeah, I like that very much. I can collect these gems, and I can push the rock down. This is okay. Nothing gets on my head. I can move below the rocks. Yeah, this behaves really nicely. I think we have a game already. We just need better levels. Okay, let's quickly add the exit state. Exiting normally with winning and dying. Oh, I don't think we can be implemented dying either. But still, I am very happy to see this. So we have to move somewhere our check. Let's move it here. It probably doesn't really matter where we put this, but if we won or we are dead, then we call a function to print the end message, and then we exit. We could also just turn the exit loop off. Maybe let's do that instead. Yeah. Let's do this. And let's implement now the print end message. So this means that we move below the board by leaving at least a bit of space, and then if we are dead, then we print this out. If we won, then we print out how many gems we collected. That's all this does. Let's test this again. Let's collect a few gems at least. Oh no, let's first die, because we didn't test it. Bam! It works. we were killed by a rock. Let's collect a few gems at least. We have some room. And yes, we collected 8 gems. I think this stage is done now.